Mass spectrometry. So we're going to talk about a mass spectrometer, which is a device that measures the mass of atoms and molecules. And it produces positive ions that are deflected by a magnetic field according to their mass to charge ratio. And this is abbreviated by m/z, which represents the charge. The positive ions may be positively charged atoms or positively charged molecules or positively charged fragments of molecules. And these fragments are used when analyzing organic compounds. So coming to the device, so how does a mass spectrometer work? So before these steps, we have to have the sample enters here, and it should be in the gaseous state. And so a heater vaporizes the sample. So the sample being analyzed must be in the gaseous state so that the particles of the sample can move easily throughout the machine. So it is injected into the mass spectrometer where it will be vaporized at first. And at the same time, after it's being vaporized, the vapor will be bombarded with high energy electrons that are done by the electron beam source or the electron gun. So this is the first step, which is ionization, where the sample is vaporized before being passed into an ionization chamber, where it is bombarded with a stream of electrons. And so the electrons will collide with the atoms or the molecules of the sample, and one or more electrons are removed from the atoms or molecules to give us or to form positive ions. And then acceleration occurs, which is an electric field that causes the positive ions to accelerate into the next step, which is deflection. And deflection occurs in the magnetic field right there, where positively charged ions are deflected by the magnetic field. So the electric field causes the positive ions to accelerate, and then the positive ions will enter and are deflected by the uniform magnetic field that's right here. And the amount of deflection depends on the mass to charge ratio of the ion. So if ions with a large mass to charge ratio are deflected, less than the ions with a small mass to charge ratio. So if all ions have the same charge, usually the +1, the extent of deflection is inversely proportional to their mass. And the last step that we have is detection. So detection when an ion hits the detector and the charge is neutralized by an electron jumping from the metal onto the ion. And this generates an electrical current which is proportional to the abundance of the ion. So we have only ions with a certain mass to charge ratio will pass through the slit and then they are detected. The ions that the strength of the magnetic field is being changed to detect the positive ions with other mass to charge ratios. So let's give a brief example about the mass to charge ratio. So for example, if we have an ion with a mass of 28, and we have the charge of this ion is +1. And then we have another sample or another ion. It will be detected at the same time of this ion with a mass of 58, and the charge is +2, 56. And the charge is +2. So in order to know the deflection, which one will be deflected first in the mass spectrometer, we need to calculate the m/z ratio. And the m/z ratio is basically dividing the mass given divided by the charge that we have of the ion. And so 28 divided by 1, that's 28, and 56 divided by 2, that's 28. So we conclude that an ion with a mass of 28 and a charge +1 will be detected at the same time as an ion with a mass of 56 and a charge of +2. And that's it for the mass spectrometer. Thank you.